Our test today has just been working out the code on the Arduino, trying to make sure that when this thing's moving, that it's reading angles, and especially that the motors are firing up when they need to and how fast. Sometimes they have a mind of their own and want to go up to as fast as they can. And so we've just been working out all the kinks in the motors and making sure that this thing is going to fly how it should fly and not how it can fly at max current. So my part of the job has been basically the hardware and the structure itself, building this, trying to make it as light as possible, making sure that each motor is getting power from the ESC, from the Arduino, and from the batteries as well, so that everything is speaking to each other and getting as much current as it needs to pull the helicopter up.
This summer, my job was to be the Simulink lead, which is for basically programming this thing up to do the control code. We started off in Simulink, which is a sub-program of MATLAB, and what we did with that is we put in all the equations of motion and we were able to control that using a PID controller.
What we used MATLAB and Simulink for was, it was very helpful in basically setting up the simulation to make sure that our control code worked before we even implemented it into a physical system. And Mathematica is just an extremely powerful math tool that can run all sorts of calculations once you know how to use it.
Biggest problem has been keeping this lightweight and keeping it big at the same time. The three main things are cheap, strength, and structure, and it's always pick two, drop the other. Ours is big, ours is heavy, and but it's very strong, and this thing isn't going to crash and break. So we've been trying to just make sure that this thing is not going to lose power in the middle of a flight or is going to lift off the ground at all.
So far, absolutely, I think it's been a success. I mean, we've gotten pretty much what we wanted to do up to this point, and I feel confident that everyone here can do exactly what needs to happen.
This is a very risky part of the mission. You land soft, you land hard, or you crash and you ruin the mission. Risk assessment is a big part of the mission, and there will be a lot of checks to make sure that this is going to work out the right way. There will be plenty of tests, plenty of checks and balances to make sure that this part is right on the knob.